Hello, today we are looking at generating sequences. Now, there's lots of different ways you can do it, and we are going to use the term-to-term rule that we were looking at last week. Sometimes these are called extending sequences, but I personally prefer the word generating because it means you are making it. Just like an engine is generating energy and motion for the vehicle or the object to move. When you're generating a sequence, it means that you are creating a sequence. As you can see here, I've got some rules written down already, and we're going to go through this and show you how to generate sequences. Now, it's also worth noting to read the question carefully. In all of these examples, I just want you to do the first 5 terms. In that, I mean the first 5 numbers in the sequence. Sometimes it might not be numbers you're generating, it could be shapes. So read the question carefully. When you're doing these, they are normally 2 to 3 mark answers, depending on the complexity of the calculations involved. Likewise, if you're told to generate 5 and you only do 4, you'll lose a mark. If you're told to generate 5 and you generate 6 or 7, again, you will lose a mark. So make sure that you always generate the correct number of terms for the sequence. As normal, I'm going to do 4 worked examples and then it'll be over to you to do the next 4. Okay, let's get started. So here we go. Starting from 5, add 3. Now, like we said before, we always need to know our starting point or the first term. And we need to know what we're doing to go from step to step to step. So starting from 5 is easy. I'm going to jot that down there. Okay, I'm going to colour code it again so you can see where this is coming from. Starting from 5, there's that there. Now we are told we need to add 3. So you need those steps, and each time you are adding 3, adding 3, adding 3, adding 3. Now when I've written this out, you will note that I'm only doing 4 lots of adding 3, because what I'm looking for is I'm looking for the terms in between steps. Okay, right, let's work this out. 5 add 3 is 8. That's your second term done. Your third term, 8 add 3 is 11. 11 add 3 is 14. And 14 add 3 is 17. Why am I writing 13? My apologies. 17. So you can clearly see 5, 8, 11, 14, 17. We've got the terms written down. Same principle again for 2. Starting from 12, subtract 4. So starting from 12, that will be my first step. There. And this time, each time we are subtracting 4. So we need 1, 2. Okay, right, here we go. 12 subtract 4 is 8. 8 subtract 4 is 4. 4 subtract 4 is 0. But we don't just stop there. You are aware that the number line goes beyond that 0. Okay, so in all of these questions you have to be prepared for some of the answers to be simple fractions, simple negative numbers, or if Pearson's are feeling particularly mean, simple negative fractions. Be aware of this. 0 subtract 4, negative 4. 1, 2, 3, 4, 5 terms, and remember the commas go between numbers. Excellent. Okay, that's 2 done. Now both of these, I've got my colour coding on there. Both of these already we can see that these are going down in even steps. And remember, we talked last week about what sort of sequence they are, and these are arithmetic progressions, arithmetic sequences. So both of these are an example of an AP. 3. Starting from 80, halve it. Now, because this step involves multiplication or division, it means it's a geometric sequence, GP. Okay, geometric progression, sorry, used the wrong abbreviation. So you have to be able to recognise if it's an AP or a GP. Same principle though, starting from 80. We are halving it. So I'm going to do this 4 times. Divided by 2. Divided by 2. Divided by 2. Divided by 2. Okay, why have I written the 80 like that? There we go, that's clearer. Half of 80 is 40. Half of 40 is 20. Half of 20 is 10. Half of 10 is 5. 1, 2, 3, 4, 5. Excellent. All done. Final one, starting from 3, triple it. So 3 is my starter, and I'm tripling it, which I know is the same as multiplying by 3. So 3 is my starter, and then I'm going to multiply it by 3. Multiply it by 3. 3 times 3 is 9. 3 times 9 is 27. 27 times 3. I don't know that off the top of my head. So I'm going to do a jotting. These questions regularly, we do not expect you to know the answers straight away off the top of your head. So 27 multiplied by 3. 21, 60, 81. And again, I don't know 81 times 3, so I'm going to do a little jotting. 3 times 1 is 3. 3 times 8 is 24. 243. And again, because this term to term part is a multiple, this is a GP. Geometric progression that we looked at last week. 5 examples here. I want you to find the first 5 terms of these sequences, and can you also please state whether they are APs, arithmetic progressions, or GPs, geometric progressions. As normal, pause the video and then check back in to see what your answers are. Okay, let's go through the answers. So, starting from 2, add 11. 2 plus 11 is 13. 13 plus 11 is 24. 24 plus 11 is 35. 35 plus 11 is 46. 1, 2, 3, 4, 5. Stop it there. Again, looking at this key part here, because it's going up with an add or subtract, we know that that is an AP. Number 6, starting from 30, subtract 8. 30 subtract 8 is 22. 22 subtract 8 is 14. 14 subtract 8 is 6. 6 subtract 8 takes us into negative 2. 1, 2, 3, 4, 5. Lovely. And again, that's a subtract 8, so it means it's going up and down in even steps. AP. Starting from 12, halve it. So I've got 12, 6, 3, 1.5. Oh, no, that's tricky. 1.5. I don't know what it is, so I'm going to do a jotting. As I say, any of these, if you're not sure what it is, do a jotting, do your working out, and that working out forms part of your work. Okay, so 1.5 divided by 2. Well, half of a half is a quarter. Half of 1 is a half, and a half plus a quarter is 3/4. Lovely. And again, looking at this, because it involves multiplication or division, it's a geometric progression or a GP. Final one, starting from a third, add 2. So we've got a third, 2 and a third, 4 and a third. Don't need a comma there. Commas between numbers, not within numbers. 4 and a third, 6 and a third, 8 and a third. 1, 2, 3, 4, 5. And again, going back to here, because we're adding 2, it is another example of an AP or arithmetic progression.